Hello everyone, welcome to the discussions of the past year questions. This video we shall discuss about the further mechanic, May-June 2022, paper 31. Okay, let's take a look at the first question. A particle of weight m, 10 Newton, is attached to one end of a light elastic string. The other end of the string is attached to a fixed point A on the horizontal ceiling. A horizontal force of 7.5 Newton acts on the particle in the equilibrium position. The string makes an angle theta with the ceiling. The string has natural length of 0.8 meter and the modulus of elasticity 50 Newton. Find the tension in the string. So over here, what you can do is that since they give you the data here and the particle, you can resolve the forces vertically and horizontally. This will be a theta. If you go for vertical forces, it will be this is the 10 Newton, the weight. That means you will have the T here. So you have a T sine theta is equal to 10 Newton. Okay, that is your equation number 1. And for the horizontal forces, you will have T cos theta is equal to the 7.5 Newton. That will be your second equations. So to find T, just take the 1 square plus 2 square. You will have a T square is equal to the 10 square plus the 7.5 square. So over here, just square root it, then you can find the T. So therefore your T will be 12.5 Newton. That's all. So this will be the answer for the part A. Okay. So from here, since we found that the T is since we found that T is at 12.5, so from the equation 1, you will get 12.5 sine theta equal to 10. Then you can get your sine theta. Press a calculator, you get 0.8. Okay. So from here, you can actually form a small triangle about this theta. This is a 4, this is a 5, and this is a 3. Okay. So for Hooke's law, because it's elastic string, so in the Hooke's law, you have a lambda x over the L is equals to the T. So your lambda given is a 50, your x is the extension, your L is a 0.8. From here, you can find the extension. Press a calculator, you can get the extension is a 0.2 meter. So the whole length over here, natural length is 0.8 plus extension is 0.8 plus 0.2. You have a total of 1. Okay, so from here, this is the data. This is the height. This is a 1.0 meter. Okay, so we having h over the 1 is equals to the sine theta. So therefore, your h is a sine theta, is a 0.8. Done. This will be your vertical distance between the particle and the ceiling. That will be the answer for the question number 1B. Okay, now we move on. Question number 2. One end of a light inextensible string of the length A is attached to a fixed point O. A particle of mass M is attached to the other end of the string. The particle is held at the point A with the string taut. The angle between OA and the downward vertical is equal to alpha, where the cos alpha is equal to 4 over 5. The particle is projected from A perpendicular to the string in an upward vertical direction with a speed of square root of 3GA. It then moves along a circular path in the vertical plane. So this is a vertical circular motion. The string first goes slack when when it makes an angle theta with the upward vertical. Find the value of a cos theta. So this one also quite routine. So you have a string in extensible, makes an angle alpha with the downward vertical. Then you're moving up with this way with your u equal to the square root of 3GA. And when you move until here, when you make an angle theta, then it becomes slack. Okay. So over here, quite obvious, we need to use conservations of energy. So you have a GPE gain is equal to the KE loss. So you have MGH equal to the half M of the U square minus the V square. And then you have a V square equal to the U square minus a 2GH. Your U is given as the square root of 3GA. So this one is 3GA. Your H, this is your H. Your H is A cos alpha plus the A cos theta. We already know cos alpha is a 4 over 5. So this one is a 4 over 5A plus the A cos theta. That is your H. So I just put it here. I get 4 over 5 plus the cos theta. That is my V square. I call this one equation number 1. Then I resolve the forces at here. I resolve the forces to the center of the circle. D plus the mg cos theta is equal to the mv square over the a. Your t is a 0. That means your v square is equal to the ga cos theta. That will be your second equations. 1 equal to 2. So you have the 3ga minus the 2ga 4 over 5 plus the cos theta is equal to the ga cos theta. All the ga can cancel. So you have 3 minus the 8 over 5 equal to the 3 cos theta. Then join together, you have a cos theta is equal to the 7 over 15. Done. That will be the answer for the question number 2. Okay, so now we move on. Okay, now we take a look at question number 3. Particle P is moving in a horizontal straight line. Initially, P is at the point O on the line is moving with a velocity of 25 meters per second. At time t second, after passing through O, the accelerations of P is given as such in the directions of PO. Okay, so you are going this way, directions of PO. Okay, so that means it's a negative directions. Okay, your acceleration is a negative directions. So you can start from A equal to the negative 4,000 divided by the 5t plus 4 cube. Okay, then they want you to find x in terms of t. We want to find in terms of t, so your A will put it as a dv dt. Do the separable variables, or you can just integrate the v. This is what you will have. So this one you get a v. This one, if you integrate, you will get this one as the 4,000 divided by 2 divided by 5 and 5t plus 4 square plus a c. Simplify it, you get a 400 divided by this. So the question telling you that at the beginning, when t equal to 0, your v is equal to 25. So you have a 25 equal to the 400 divided by the 4 square plus C. That gives you the C is a 0. So means now the V, it will be supposed to be like this, 5t plus 4 square. But the question wants x in terms of t. So we need to change the V back to the x dt. Do the integration one more time. This time we can find the x. Like that. Then x is equals to the negative 400 divided by 5 and 5t plus 4 plus the d. Then when the t is equal to 0, x is 0. So you will get this as the negative 400 divided by 20 plus a d. So the d will be 20. Okay, d will be a 20. Therefore, your x is equal to the 20 minus the 80 over the 5t plus 4. That will be the answer. Of course, if you want, you can join these two up, become one fractions. Then you're supposed to get 100t over 5t plus 4 if you combine them together as one fractions. So this will be the answer for the question number 3. Just like that, done. Okay, so now we move on. Okay, now we take a look at the question number 4. You have a diagram here. This is the object composed of a hemispherical shell of a radius 2a attached to a closed hollow circular cylinder with a height h and a base a. The hemispherical shell and the hollow cylinder are made of the same material. The axis of symmetry of the shell and the cylinder are coincide. AB is the diameter of the lower end of the cylinder. Okay, then find in terms of A and H the expressions for the distance of center of mass of the object from AB. Okay, so we are looking for the distance here, the bar y, and we're looking for the bar y. Okay, because we know that the since it's symmetric, there's a symmetrical axis. That means the center of the mass must fall into the axis of symmetry. It's just that we do not know how high is it. So now what you need to do is we draw a table. So we have the solid. Okay. So we have the hemisphere. It's actually a shell. And then we have a cylinder. And then after that, we have a combined material, combined object. Since they are building with the same material, we can consider the volume. But actually, they are all hollow. This hemispherical shell and also the hollow circular cylinder is, we can only consider the surface area. The surface area. Surface area for the hemispherical shell will be half of the 4 pi r square. So it will be half of the 4 pi r. Half of the 4 pi r square is 2 pi r. 2 pi r square. Then cylindrical area, it will be 2 pi a square plus the 2 pi a h. And then if you combine them together, you have the 10 pi a square plus the 2 pi a h. So this is the center of the mass from AB. For the hemispherical shell is according to the formula booklet, just check the formula booklet, the height is actually half of the radius. Okay, so it's a H plus A. H plus A. Then as for the cylinder, since you have a symmetrical line, so it will be half of the H. And this is the bar Y. Okay, so now we are ready to do the moment, to find the moment about the line AB. So you have a x by a square H plus A plus the 2 by a square plus the 2 by AH of half of the H is equals to the 10 by a square plus the 2 by AH bar Y. All of them can divide the by A, okay? Can divide 2 as well. So if you divide 2 and divide everyone by 2 by A, so I get 4 AH plus A square. Then this one, you get an A plus H. This one you get a 5A plus 2H. So now you join together. If you join together, then you get a bar Y is equals to the 8AH plus 8A square plus the AH plus the H square divided by the 2 of the 5A plus 2H. Join together, you will have 8A square plus the 9AH plus the H square divided by 2 times of 5A plus 2H. Oh, wait, I make a mistake. This is not 2. Okay, I have divided 2. So this one is only H. There's a H only? No, 2. Okay. Okay, so this will be your bar Y. We cannot simplify further. We just leave it like that. That's all. Okay. So this is the answer for the part A. Now part B, we are having this object placed on the rough plane which is inclined at the horizontal at an angle theta where the tangent theta is 2 over 3. The object is in equilibrium with the AB contact with the plane and lying on a line of greater slope of the plane. Find the set of possible value of H in terms of A. So you are resting on an inclined plane, something like that. Okay, you're resting on that. So your center of the mass. So in order, the maximum you can get is that it must pass through the corner of the base of the core of cylinder. Okay. So from here, from this part, oops. From this part over here, if you take it up, this is the theta, this is the bar Y, this is the radius. Okay, so you can see that your A over the bar Y is equal to tangent theta. Okay, so to be more precise, your A over bar Y must be actually greater than the tangent theta, or the tangent theta must be, or we can say that the tangent theta must be less than equal to the A over the bar Y. Okay, so your center of the mass at most is can only reach until this corner of the base. So your tangent theta must be less than that value. Okay, your tangent theta must be less than this value, or equal, and most is equal to this value. So tangent theta, they give you tangent theta is a 2 over 3. And then our bar y from the part A, the bar y just now, the answer is 8a squared plus 9ah plus h squared divided by 2 times 5a plus h. So over here, you will get this as the 2 multiplied by 8a squared plus 9ah plus h squared. This one you will get 6a of 5a plus h. Expand and simplify. Okay, so if you expand and simplify, this one you can cancel the 2. So you will have this one as a 15a squared plus a 3ah. This one you will get 8a squared plus 9ah plus h squared. Then you will get h squared plus the 6ah minus the 7a squared is less than equal to 0. Factorize it. Plus the 7a minus the a. So you will get the answer that the h is between negative 7a and a inclusive. Okay, but because the h at most the h is a 0, h is the height of the cylinder, so the h cannot be negative. So therefore you can only say that the h is from 0 until a. Okay, so this will be the answer for the question number B. That's all. Move on. Okay, now we take a look at the questions number 5. A line in extensible string AB passes through two small holes C and D in a smooth horizontal table where the AC equal to the 3A and the DB equal to A, as given here. The particle of mass M is attached to the N. This is a M, so the weight over here is mg. And then the particle of mass B is 3 over 4 m. So this will be 3 over 4 mg. Okay, and they are sharing the same tension. They are sharing the same tension. Okay, so but this one is moving with the angular speed of omega. This one is moving with the angular speed of k omega. Okay, so we just need to consider case by case, A and B separately. So at A, if I resolve it, the forces vertically, since they mentioned this is a theta, so this will be a theta. So it will be d cos theta is equal to the mg. Okay. Then I call this one equation 1. Then if I resolve it horizontally, I have a d sine theta is equals to the m. What is your R1? This one will be a 3a sine theta omega square. You can see that the sine theta can be cancelled off. Then you have a d is equal to the 3ma omega square. That is your equation number 2. Then at B, if I resolve the forces vertically, over here, this is the data. Okay, this is the data. Then if you resolve the forces vertically, you have d sine theta equal to the weight of 3/4 mg. Okay, we can just call this one number 3. Then if I resolve the forces horizontally, I have a d cos theta is equals to the 3/4 m. Your R2 is the radius of A cos theta. Your angular speed is k omega. So over here you will get T cos theta. This one can cancel. You will get T is equals to the 3/4 ma kma omega square. That will be your equation number 4. We're looking for K. We're looking for K, so I think the equation 2 and equation 4 should be enough. Take the equation 4 divided by equation 2. So you have a d equals to the d divided d is equal to the 3/4 of kma omega square divided by 3ma omega square. So ma omega square cancel. You have a 1 equals to the 1/4. Oh, I forgot to square it. This is a k square. So your k square equal to 4, that means your k is equal to 2. Your k is positive. Okay, k is positive. So that's all. Find the value k. Yeah, done. Okay, so this will be the answer for the question number 5. Okay, so now we move on. Okay, question number 6. Two uniform smooth sphere A and B of equal radii have masses m and km respectively. The two spheres are on the horizontal surface. Sphere A is traveling with a speed u towards B, which is at the rest. The sphere collide immediately before the collision. The directions of A makes an angle alpha with the line of center. The coefficient of restitution between the sphere is half. So it will be something like this. So A is moving with the speed u, makes an angle alpha with a line of center. So we have before and after. Okay, before and after. B is at rest at the beginning. So after the collision, it will be moving horizontally. So this one, it will be your VB. This will be your VA. At the beginning, your A make an angle with the alpha. This is a U. Okay. Then after the collisions, I do not know the angle. I call it theta. Okay, this is what we have. So if you consider the principle of conservation of linear momentum, okay, that means you're going for horizontal forces. So you have a m, this is the m, this is the km, this is the m, this is the km. So you have a m u cos alpha plus 0 is equal to the m va cos theta plus the km vb. Cancel all the m. So you have a va cos theta plus the kvb is equal to the u cos alpha. Equation 1. Then the Newton experimental law tells you that the E is equal to the negative of the VB minus the VA cos theta divided by the 0 minus the U cos alpha. Okay. Then they give you the E is a half. E is a half. So I just direct change the E here, become half. The negative and the negative here cancel. I get the VB minus the VA cos theta is equal to the half U cos alpha. I have this one as an equation 2. I want to find VB. To find VB, I just take equation 1 plus equation 2. Then you can get the VA cos theta cancel off. You have a 1 plus K VB is equal to the 3 over 2U cos alpha. Then your VB is equal to the 3U cos alpha over the 2 of 1 plus K. Shown. That is the answer for the VB. But the question also wants you to find the speed of A after the collision. That means we want to find the along the line of center. That means we want to find VA cos theta. So VA cos theta, just put back either into the equation 1 or equation 2. I put back into the equation 2. Then I get the VA equals to the VB minus the half of the U cos alpha. So it will be 3U cos alpha over the 2 of 1 plus K minus the U cos alpha over 2. So you get this as a 3 minus the 1 minus the K U cos alpha divided by the 2 of 1 plus K. Combine them, become one fractions. Then you will get 2 minus K U cos alpha divided by the 2 of the 1 plus K. Okay. Now over here, the question didn't state that clearly the directions of A. Is it still remain the same or changes or it has changed? So we do not know. Okay. And over here, this one, is it positive or is it negative? We are not so sure. Okay. So basically, this is the answer for the VA already. It's just that we don't know it's positive or negative. But they are mentioning about speed. They didn't mention velocity. They mentioned speed. They mentioned speed. So if it's talking about speed, we will make it as a positive. So you can see that the mark scheme, they put the modulus on that. Okay. So this is the reason why they put modulus, because they're talking about speed and we do not know whether the VA, the sign has changed or not. So we just put the modulus. That's all. So this is the answer for the VA and the VB. Sorry, not the VA. I read wrongly. It's supposed to be the VA cos theta only. This one is a VA cos theta. So what we have is a VA cos theta, not a VA yet. Okay. Okay. So now we are moving on to the part B. They want to, they say that the KE final at A is equal to the KE at B after the collision. And with the tangent alpha is a 2 over 3, then they want to find the possible value of K. So what we can do here is that your tangent alpha is 2 over 3. We build the small triangle, 2 over 3. You get this one as a square root of 13. Okay. So let me just find the VB first. VB. So the VB is a 3U cos alpha. Cos alpha is a 3 over 13. Okay. Now this is what we have. Cos alpha. Yeah. Okay. Then, but we are looking for kinetic energy. So later we will have V square. So I will just have a VB square. Then I get this as the 927 U square and 52, 1 plus k square. That is my VB square. Then now at A, I want to consider the vertical component. I have the VA sine theta is equals to the VA sine theta and the U sine alpha are the same. Okay, is equal to the U sine alpha. Your sine alpha is actually 2 over 3, 2 over 13U. Okay. Then just now from the part A, we have a VA cos theta is a 2 minus a K U cos alpha over the 2 of 1 plus K. Okay. And this cos alpha is 2 minus K. Cos is a 3 over 13. This one a bit complicated. Okay. But I want to have a VA square. VA square is the VA sine theta, you square it, plus the VA cos theta, you square it. So this one will be a kind of complicated. You have a 4u square over 13 plus the 9 of 2 minus k square u square over the 52 of 1 plus k square. So this is what we have. Quite complicated, huh? So this one, you combine them together, you will get 52 of 1 plus k square. This one will be a 16 of 1 plus k square plus the 9 of 2 minus k square, the whole thing, u square. Okay, so this is what we can have. So now, given KEA is equal to KEB after the collision, that means the half m of the VA square is equal to the half of the Km of the VB square. The mass for the B is a K. Yeah. Okay. The half m cancel. So the VA square is what I stated earlier. Like this. Then the VB square is a K of the VB square. VB square. Oh, sorry, I make a mistake. Just now this one is not 27. This one, if you square everything, you're supposed to get 81. Okay. So this one is 81 u square over the 52 of 1 plus k square. Well, it looks a bit complicated, but luckily this one can be cancelled off. The u square also can be cancelled off. So at the end, you get only this. Okay. Now this one looks better. Then expand, you get a 16k square plus the 32k plus a 16 plus the 9k square minus the 36k plus the 36 equal to the 81k. So you get 25k square. Minus 4 minus 85k. Then plus 52 equal to 0. So this one definitely we will use calculator to factorize it. A is a 25, B is a negative 55, and then the C is a 52. Okay, so you get this one as the 5K minus the 13 and the 5K minus the 4. Okay, just like that. So your K is equal to the 13 over 5 and your K is equal to 4 over 5. Are they looking for possible values of K? Yes, these are the possible values of K. Done. So this will be the answer for the question number 6B. Yeah, correct. This is the answer for number 6B. And move on. Okay, now we take a look at question number 7. Particle P and Q are projected in the same vertical plane from a point O at the top of a cliff. The height of the cliff exceeds 50 meters. Both particles move freely under gravity. Particle P is projected with 35 meters per second at an angle alpha. Tangent alpha is 4 over 3. Particle Q is projected with a speed of u meter per second at an angle beta, where the tangent beta is a half. The particle Q is projected 1 second after the projections of the particle P. The particle collides t second after the projections of the particle Q. Okay, write down expressions in terms of the horizontal displacement of P and Q from O when they collide, and hence show that this is the relationship. Okay, so for the P, you have the UP as a 35 over 2. For the Q, you have a UQ as a U, and the angle of projections, tangent alpha, is 4 over 3. So from here, we can draw a small triangle, 4, 3, 5. Then for here, tangent beta is a half. Similarly, we can draw a right angle triangle. Okay, then the TP and the TQ. The time for Q is referred as T, and the time for P is referred as T plus 1, because the Q is moving 1 second later than the P, and the T is referring as the time of Q. Okay, so this is what we should do. Then if you consider the horizontal displacement for XP, it will be equal to the UP cos alpha dP. This one will be the XQ equals to the UQ cos beta dq. So you'll be having 35 over 2, 3 over 5, and this one is a t plus 1. Then your xq will be u 1 over 2 over 35. And then you have an uppercase T. So you have equation 1, you have an equation 2. No need to write equation 1 and equation 2, because we already have xp and xq. We just say that when they collide, xp equal to xq. That means the 35, 2, 3 over 5, t plus 1 is equal to the 2 over 35 ut. So simplify it, you get 21 t plus 1 is equal to the 4 over 35 ut. But they want in the form like this. Okay, so I just move the 35, go to the other side. So therefore, you have a 4 ut equals to the 21 35 t plus 1 shown. This is how you show the relationship. Okay, so for the horizontal displacement, when they collide, they're supposed to be the same. And then, of course, the next thing over here, the questions want to find the value t. We still have one more thing I haven't applied yet, which is the vertical displacement. Since they collide, the vertical displacement also must be the same. So now we consider the vertical displacement for the p. It will be the yp equal to the up sine alpha this will be d plus 1 minus a half of the g d plus 1 square. Okay, your UP is a 35 over 2. Your sine alpha is a 4 over 5. D plus 1. Then this one is a 5 d plus 1. I change the g become 10. Simplify it. So you get 2 times 7, 14 of d plus 1 minus a 5. You can expand it. D square plus 2d plus 1. Okay, that is a YP. Then this one is for P. For the Q, if you resolve the forces vertically for the vertical displacement, you have a YQ equals to the UQ sine beta T minus a half G T square. Okay, so it will be the U of sine alpha is sine beta is a 1 over sec 5 minus a 5d square. Okay, so I call this one, no need to call 1 and 2 anymore, because we can just tell that the YP equal to the YQ. Then you have a 14 of d plus 1 minus the 5d square minus a 10d minus a 5 equals to the 1 over sec 5 of ud minus a 5d square. So you can see that the 5d square can be cancelled. So at the end, you are having 14d plus 14 minus a 10d minus a 5 is equals to the 1 over sec 5 ud. So 1 over sec 5 ud is equals to the 40 plus 9. Okay. Then from the equations A, from here actually we can, so I call this one, maybe now this time I can call this one equation 1. I can call this one equation 2. Okay, I can call this one equation 1 and equation 2. So by taking the equation 1 divided by equation 2, you have a 4 ud over the 1 over sec 5 ud is equals to the 21 sec 5 d plus 1 over the 4d plus 9. Cancel it. So this one, it will be 4 sec 5 4d plus 9 equal to the 21 sec 5 d plus 1. Cancel the sec 5. 16d plus 36 equal to the 21d plus 21. So you have 15. So the d is a 15 divided by 5 is equal to 3. That will be the answer for the part B. Is the answer for the part B. And now move on. Find the horizontal and the vertical displacement of the particle when they collide. Okay, so when the d is equal to 3, horizontal displacement, what is your x? I use xp. xp is refer to this. So it will be 21 over 2 of d plus 1. So you get 42. Then for the YP is YP is over here. So it's a 14. 3 plus 1 minus the 5 of d plus 1 square. So this one, press the calculator. You get 14 times 4 minus the 5 times 16, negative 24. So it's a 24 meter, but below. Below the top of the cliff. Okay, so that will be the answer for the question number 7C, and this will be the last questions. Okay, so I stop the video here. We'll see you next time. Bye bye.